Hi, my project is called Outliers. It is an on-rails evolution shooter, which is basically the genre of games that comes from an old Duck Hunt game created for an NES console. This project was mainly created using Unreal Engine 5 and its features. The main idea is to recreate real-world natural selection, so when the player shoots an enemy, it has real influence in that next generation of the evolution line. This game mechanic fixes one of the oldest issues with game's difficulty. Instead of enemies becoming stronger to a predefined difficulty settings or curves, they adapt, because the player removes those ones that are easy to spot. The game starts in the main menu. From there, player can choose available level and begin a run. When the level opens, camera travels through the environment along a predefined rail. The player controls the crosshair with a mouse and can shoot fish using hit-scan weapon logic. Each generation contains a small population of fish. The player has limited time to find and shoot as many fishes as he can. At the end of each generation, those one who survived are used to create the next generations of fish. The evolution screen cleanly presents which fish were eliminated, which ones survived, and how the new offspring would look like. This process repeats for 5 generations, which is predefined by the first level. After the final generation, the players receive statistics from the whole run, and he gets some rewards as well. Every fish is described by a simple genome stored in the mob genome structure. For this type of game, I selected 3 main traits: movement speed, body scale, and body color. I've limited the genome on purpose to 3 understandable properties. This makes the evolutionary process visible to the player and keeps the system readable during the presentation. But I'm sure you can have fishes with giant heads as well. The core gameplay system is in a blueprint called Generation Manager. It controls the full generation lifecycle using a state system. The manager begins in the idle state, spawns a population, enters the hunting state, ends the generation, and after that displays an intermission and eventually completes the run. At the beginning of each generation, manager reads an array of available genomes and spawns a fish for each genome. Every spawned fish reports its death through the onMobDied event dispatcher. This allows the manager to update the number of eliminated fishes without tightly coupling the fish blueprint to the generation logic. When the hunting time ends, the manager identifies the surviving actors, stores their genomes, and creates a generation summary. The next population is created using a simplified evolutionary algorithm inspired by natural selection. Parent genomes are selected from the ones that have survived. Offspring inherits values which are combined from the 2 surviving parents. This ensures that its speed, scale, and color are influenced by both parent fish. After inheritance, mutation is applied. Each trait has a mutation chance and a limited mutation range. The values are also clamped to safe limits. This prevents fish from becoming impossibly fast, extremely large, or too small to shoot. Breeding process preserves successful traits, while mutation prevents every generation from becoming completely identical. Shooting is implemented in a custom player controller. Try-fire function first checks whether the generation is currently in the hunting state and whether the weapon cooldown has finished. It then performs a line trace from the player's aiming position. When the tray hits a fish, system registers a successful shot, applies damage, updates run statistics, and triggers the hit marker animation and sound. The weapon uses hit scan instead of a physical projectiles because immediate feedback is more appropriate for this type of arcade shooting game. The level uses an on-rails camera system. Every game tick, the player's current distance is increased along the rail using movement speed. The blueprint samples rail spline locations and moves the player accordingly. Mouse input doesn't move the player freely. Instead, it applies a limited yaw and pitch to add a subtle camera movement. I chose an on-rail structure because it gives the designer control over what the player sees and keeps the fish inside a predictable gameplay area. Level configuration is data-driven. This basically means that a specific database stores all levels properties. allowing an easy way to create levels without rewriting the menu or generation system. Custom game instance also store information that must survive map transitions, like unlocked levels, rewards, and more. Some visual assets, environment models, textures, and sounds were obtained from external freely available asset sources. My contribution is the game concept, gameplay architecture, blueprint implementation, system integration, interface flow, and balancing of the evolutionary mechanic. The current version is a complete playable game focused on one implemented environment. Future development could include additional biomes, more genetic traits, upgrades, and more complex movement behaviors. The project shows how natural selection-inspired logic can be transformed into a real game where difficulty emerges directly from the player's decisions.